Hello everyone. Today I'm going to show you the steps of how we can solve 3D truss. So we have here truss 3D has 3 nodes, and we have also the force 10 kilonewton applied at node number 1 on Y direction. So the first of all is you should give the number of member and the global system and also direction to make it easy for your solution. So here this one I will say is up to you, the direction and the number of member is up to you. So for me actually I will use this one is member number 1, and this is member number 2, and this is member number 3. And also the direction is look like this. For member number 2 and for 1 is look like this, and for member number 3 is this one. Okay. Second step, you should give global system numbers for 3 directions, because here we have 3D. Let me to change the color for you. Okay. So I will start from node number 1. It's easy when I solve to find which is the known force and which is the unknown force. So here this is global system number 1, global system number 2, and this one global system number 3. Go to node number 2. This is global system number 4, 5, and 6. Node number 3, this is 7, 8, and 9. Okay. Now, what is the known force? Known force is only we have on applied load on node number 1. Okay, so I will take node number 1 for two points or 2 axles, like on X on the global system on number 1 and 2 only. So the Fk equal, that means known force. On X direction we don't have any force, so it will be 0, and on Y direction we have 100 kilonewton. Okay, and for known displacement we have let me write here, for dk, d3, d4, d5, d6, d7, d8, d9. All of these known force is okay. And for unknown known displacement, and for unknown displacement we have only d1 and d2 and only d2, 1 and 2 only. Okay. Then I should calculate next step for the K matrix of member number 1. How can I do that? Here, member number 1. I should find the value of L, because as you see here, our shape is inclined and is already given the values of x, y, and z for each node. So it's easy to calculate the length. Length equals square root delta x square plus delta y square plus delta z square. Okay, this is for member number 1. You should get only the values of x, y, and z from the far node and near node. Just calculate it for member number 1 only. You will get 4, the length of member 1, and the area is already given. It's 0.04 meter square. So now delta x equal x far minus x near over L. So if you look for the shape, this is number 1. X near is 0, okay, because the direction is from the original point, okay, of Excel until the node number 3. So it will be 0 minus the x near is 0. Depend on these values. Okay. 0 over L is 4 equal 0. Same way, lambda y equal y far minus y near over L. It will be already equal 0 because we have 0 from both. In the 2 points we have y equal 0. Here is 0, and also here is 0. So it's already will be 0. For lambda z, it will be equal. Yeah, we have 4 here. For the far node, we have 4. So the far node is 4 minus 0 over L equal 1. Okay. Then next step is up to you. You can get the value of lambda x square and lambda y square and lambda z square. Just put, for example, here we have lambda z. Lambda z is 1. Just put 1 square, it will be already 1. Okay, and time each one of these values. Okay, time a over L. Okay, and put it in the matrix. It's up to you. I don't like to make it confuse. You can get out as common factor, or you can add it in the matrix. It's up to you. Okay, so let me show you. I will do lambda x square time A, the area, over L. It will be equal 0 because the lambda x is 0 here. So it will be 0. Lambda y square time L over L. Sorry, A over L. Sorry, here I don't have any square. Yeah. It will also 0 because the lambda y is 0. Lambda z square times A, the area, divided by L equal 0.01. Okay. Then also for in the matrix, actually, I will show you the form of matrix soon now, but just give me this to give you this step. And also we need in the matrix, this value is lambda x, lambda y, time L over A over L equals 0, because lambda x 0 and lambda y 0. Lambda x time lambda z time L over A over L also equals 0, and lambda y time lambda z time L over L equal 0. Why you should find these values actually and put it in your side, okay? Because the form of matrix that we follow is look like this one. The K matrix, okay, the member stiffness matrix, global coordinate equal K dash equal lambda x square lambda x lambda y lambda x lambda z minus lambda x square minus lambda x lambda y. Sorry, I don't have space. Let me to make it better. Here K dash equal, okay, the value A E over L, and then the matrix of, okay, the matrix of lambda. But we already got the value of yeah, okay, sorry. So I don't like to make or to compare what I'm done. Just put it like this, okay? And here the values of lambda, okay? So now the matrix of lambda or K matrix is look like this. Here lambda x square, lambda x lambda y, lambda x lambda z minus lambda x square minus lambda x lambda y minus lambda x lambda y, okay? Then lambda x lambda y, it's similar actually. Then lambda y square lambda y lambda x z minus lambda x lambda y, then minus lambda y square, then minus lambda y lambda z. Then the third cell, lambda x lambda z, lambda y lambda z, and lambda z square minus lambda x lambda z minus lambda y lambda z minus lambda z square, okay? Lambda z square minus, okay? So here is actually okay, now we have 3 rule. So the others 3 is just change the sign of Linda. Like for example, then for the cell number 4, it will be minus Linda x square, same this value, but in opposite sign. Okay, the cell, next cell is minus Linda x Linda y. Okay, then minus Linda x and Linda z. Okay, and here Linda x square, it's positive, not negative. Then Linda x Linda y in positive direction, and Linda x Linda y. This part is same with this part, but only opposite sign. Also for the these cells, okay, is same with this one, but in different sign. Okay, and also the last one, it will be same with this one, but in different sign. I mean, or opposite sign. Okay, same things, same the value of Linda. Okay, so now I just to add something. This is the nx, the near point on x direction, and this is ny, this is nz, fx, fy, and fz. Okay, okay, look like this, just to show you, because the screen is so small. I'm very sorry, but I hope you to give some idea to understand. Okay, this the matrix that we follow it when we solve each K matrix of each member. Okay, but in the last previous slide, when added this one, this step, okay, because and also this one, okay, these two parts, because I put it A over L inside the matrix, okay, so that when we solve, and if you like to depends on my solution, so in my solution I just put it E outside here, because to make it easy for you to calculate. Why? Because you have different value of A. Okay, if you go to the first slide, our question, we have A1, A2, and A3. Also, when we have these values of different number of Excel, so it will be also the different length. Okay, so we have L for member number 1, L2 for member number 2, and L3 for member number 3. Okay, so that to make it easy and easy to get a value without any confuse, just put this values A over L inside the matrix, because we have a different value of A and also different value of length of each member. So now it's easy to find K1 1, because now we are in the member number 1. Is just put it E, the value of E, times 10 for power minus 3, because we want to change the value to get a small value. Okay. Then the matrix, it will be 0, 0. First of all, we let me to see the. Oh, okay, I remember it. We have the member number 1 is look like this one. Okay, and we have 3 global system. This is 4, 5, and 6, 7, 8, and 9. Okay, so here this is nx. Nx is 4, ny is 5, n6 is nz is 6, and then fx is 7, fy 8, fz 9. Okay, then substitute your values, okay, of Linda that I already calculated from this part. Okay, depends on this matrix. So here 0, 0, 0, 0, then 0, 0, 0, 0, 0, 10, 0, 0 minus 10. To make it fast, actually 0, 0, 0, 0, and here 10. Same way, this is 4, 5, 6, 7, 8, and 9. Okay, then same way you can calculate for member number 2. Same way, find the value of L. So value of L will be square root 3 minus 0 square plus 5 minus 0 square plus 0 minus 4 square equal 50. Okay, how can I get these values? You can go to the point of member number 2 for this one. So it's now I'm working on member number 2, so I will take this node, so these values, and with these values. Okay, depends on this one. How can I calculate the length? Okay, then find Linda x equal 3 minus 0 over length. It will be equal 0.424. Linda y equal 5 minus 2 over 50 equal 0.7071. Linda z equal 0 minus 4 over length equal minus 0.5657. Okay, then the value of Linda x square time a over L equal 0.0018. Linda y square time a over L equal 0.005. And the last one, and yes, same z Linda z square time a over L, you will get the value same way. Okay, then write the matrix K2 equal E time 10 for power minus 3, because I want to get a small value. Okay, and the matrix, it will be 7 for nx, ny8, nz9, fx1, fy2, and fz3. This is the global system. Same thing, this is 7, 8, 9, 1, 2, 3, because this is member number 2, and this is the direction on 1, 2, and 3. Here's 7, 8, and 9. Okay, so depend on the directions and global system, you can substitute your value, like here 1.8, 3 minus 2.4 minus 1.8 and minus 3, 2.4. Here it will be 5 minus 4 minus 3 minus 5 and 4, and so on. You can complete the values. Same way you can get the K3. Okay, same way you can do by your own. Okay, so then how we can find the D, the unknown displacement for global system number 1 and number 2. You follow this rule, Fk and Fu, unknown force, this mean, equal K11, K12, K21 and K22. Okay, and also we have D, du, unknown displacement, and dk, known displacement. Divided the matrix to make it easy calculate. Okay, because for to calculate this value, just to take K11 and K12 and Fk. Okay, so it will be like this, Fk equal K11 du plus K12 dk. dk is, as I mentioned before in the second class, second slide, dk is 0, so this term will be equal 0. Only take this part, okay, because you have supports, two support. It look like this. We have support here and support here. If you remember the shape, okay. So only this one is free. Okay, so now calculate unknown displacement. So then substitute your value for for fk equals 0 and 100. This is 1 and 2 global system. So here same way you should take 1 and 2, 1 and 2, and then D1 and D2. Okay. The values that I got it, D1 and D2 equal 10 for power number 3 and over E. D1 equal 2542 minus 1516. Okay, so this is just substitute or time this value multiplied by this value will get exactly the value of D1 and D2. Then how we can solve internal force. So for internal force, like in the 3D force, 3D truss, internal force, I will take number 2, just same steps. Okay, you can do by your own, but just I show you the steps how we can solve the 3D truss. F for member number 2 equal AE over L. I don't have space, so here it will be here, there. Here we have matrix, and then also here we have a matrix. So for horizontal matrix, this one, minus lambda x minus lambda y minus lambda z, then lambda x, lambda y, and lambda z. Okay, then the value of this matrix, the vertical matrix, okay, we have, it's depend on the global system of your member. Okay, let me to draw here, or this one, we have member number 2, and this is the direction. Okay, so this is the near point and this is the far point, or not, up to you. So here we have global 1, global system number 2, and the global system number 3. Here we have 7, 8, and 9. Okay, so I will substitute directly. Here we have D7, D8, D9, then D1, D2, and D3. This is the value of this matrix, the D matrix. Okay, so in this our example, D7 is 0, D8 is 0, D9 is 0, D1, this value we got it 2542 times 10 to power 3 over E. Okay, and here the value of D2 minus 1516 times 10 for power number 3 over E. and the D3 is 0. Okay, so same rule and same the steps of how we can substitute your value of D and Linda. And also here internal force, you should find it for each member. So here I'm talking about member number 2. So you can do by your own for member number 1 and also for member number 3. Just to show you how we can solve the general step. Actually, I didn't go too deep and to find each value values one by one for you. You can do by your own. It just take time actually. So now the F equal F F1 equal 0 for F1, and F2 internal force number 2, it will be 584 kilonewton. This is tension because it's positive, not negative. F3 equal 620 kilonewton. Also this is T because it's positive. Okay, so that's all for how we can solve and find the internal force for 3D truss. Thank you so much for kindly watching and listening.